hello guys. I sort of forgot about this. Been a lot at work, so let's pick up where we left off with frames per second and delta time. And I think I'm going to cheat on the frames per second and just utilize SDL's tooling for this. So let's just switch to there. We have our project. It builds. We can make it run. Arrow keys. Move the thing. That's good. Seems reasonable. Oh. So everything's just one file. There we go. So what did we want to do today? We wanted to we wanted to utilize delta time, right? Because we don't know the frame rate. Currently, I think this screen is 60 frames per second. But if somebody plays my game with 120 frames per second, this velocity here, what do we set it to? We set it to 1. And yeah, this will, I think we have a super high frame rate here as well. Do we have? Yeah, no. We only have accelerated renderer, so we don't have VSync. So let's start with enabling that and see what happens. Still renderer present VSync, and we have the accelerator. Can we run that? So now it hardly moves. Okay, that's perfect. So what we did now was present VSync will synchronize this call still renderer present. If I remember it correctly, it will synchronize that call with the actual frame rate of the computer, what it's currently running with. So in my case 60. So essentially that call will block until the frame has finished updating. You can do this manually by just maintaining how much time has passed within this loop, within this. How much time has passed when we reach the end. Compare that to how much time we want to spend on each frame, and kind of sleep the loop until that time has been reached if we're way under. So before this, we were probably hitting this loop, iterating this loop a couple of times per frame. So we added the velocity 1 to the player's position multiple times per frame. But now when we enabled virtual synchronization or vertical synchronization, I don't know. We are just adding 1 to player 1's Y position per frame. So that's why he got a lot slower. What we want to change now is we actually want let's just paddle speed. I'm just guessing it. Let's say no 100. Oh no, 200. Let's say we want the paddle to move at 200 pixels per second. So we want to cap that. We want to instead of defining how many pixels we should increment the position with, we instead tell it that the speed is now how much we want it to move per second, and in pixels. So that's 200 pixels per second. If we add paddle speed here instead, and let's see how this runs now. Trying to it's mega fast, because what we're doing now is we're moving 200 pixels per frame. So how do we change that to be per second? That's where delta time comes into the picture. So delta time is a float. We often call it DT. We can start it at and 64 of those defined. Okay, so we have we have uint64t, which is the C default, and then we have uint64, which is the SDL one. I will set that to SDL get ticks. I just never remember how to do this. We have the speed, we have the delta time, which is 0 here. And here, this is where we do our moving thing. So at this point, we want to set delta time equals float get ticks. This is divided by, no, this is going to be the like minus end divided by 1000. And wrap that one like so. Frame end. We'll do all our operations, and then we will set frame end equals SDL get ticks. And there is an issue here. I'm going to multiply that with delta time. So let's explain. SDL get ticks is an arbitrary amount of time since since the application started. It will always be larger or equal to the previous time you called it. And essentially what we're doing here is, in this little section, is get the ticks now, subtract how long time has, but like subtract the last time step we checked, and divide that by 1000. The 1000 is representing a second here. So that's, we're figuring out a float value, which is how long time did the last frame take to render, which is the delta time value. We then use that delta time to multiply with our velocity. So think of it as delta time will be an increment of a second. Essentially how long a frame takes to draw. And if we multiply that with our velocity, which in this case is 200, representing 200 pixels per second, we will get a fragment of 200, which represents how much should we move this frame. And this will update, so if the frames get slower, delta time will get larger, and vice versa. So how much did the frame take to draw, and how much should we move if we intend to move 200 pixels per second? That's the plan. Now I am prepared for, we might have an integer problem here, that if this value, p1 velocity times delta time, is almost 0, this integer value, player 1 y position, will never really increment, because it will always round down, and because we're casting it in integer, so it might always end up at 0. We'll see. Let's see if I did it right. We'll run this. Oh, so yeah, we're moving pretty slowly, but it's working. Why is it complaining about? Oh, I didn't even write int. That was funny. Let's make it an unsigned integer. I forget what's the nice way of doing this. Make it big. Capital case. No, capital I use for defines. We could have used a define here, but then I skip around the code and it's hard to follow. So we have our player, and he's all integers. So I was expecting this. Now we have to pay for this thing we did earlier. So we'll change this. Struct paddle, and it has a float x, float y. Width and height could still be an integer, so let's do that. Int width, int height. There. Now this is going to get all whiny. We'll just cast that to float here. Cast this to float, but let's just wrap the whole thing. Forget this math. Float, cast that one too, and cast this one, I guess. Now if this had been C++, we would make some nice function which kind of does this for us, but we can't, so we'll have to live with it. And this is no longer an STL-rect. Actually, maybe, I wonder if that would have sufficed. Let's delete all that, see if it still complains. This is it's a definite. I didn't do my type def. No, I did it right. Okay. So no, apparently it's not complaining about us not casting, but if we had more compiler warnings, I don't know, do we have those? It would probably say that, oh, you're casting, that's not good. What's this problem then? Yeah, of course, because this is no longer a rectangle. So instead, we'll have to. I wonder if can I be really lazy? Let's just do them here. P1 box. Oh, let's just reuse the same one. I wonder if this works. No, so we'll do it like this. Width, P1, width. This is always the same, so it's kind of stupid. We probably shouldn't define that in the player paddle things. X, P1.x. I'll do the same for Y. And then we'll do it. This is ugly, but yeah, it's not that fun watching me do structure code really either, is it? So now we use the same SDL rect and we shape it after. We position it after the player's position, and then we use that as a template for drawing. We'll just call it, oh, let's rename it. What is it? Paddle box. And since those never change, we can just set those. Or we just set the positions here instead. Compile that. Does it run? There. Still pretty slow. 200 pixels per second is not a lot, is it? I have a pretty high resolution on this screen too. There's this setting I've always never really understood. We might want to check that out. This feel render. No, that's not the one I'm looking for. Is it here? Window. It's not full screen. It's oh, there it is. Allow IDPI. Let's see if that makes sense. Just so it will look the same on different screens. I'm not quite sure how that one works. Okay, so that did nothing. I don't know what that one does. Let's just ignore it. And I guess we're not happy with that speed. It feels really sluggish. It feels really sluggish. Where do we put paddle speed? Paddle speed. There you go. So do we go 500 instead? That's more reasonable. It's still a bit sticky, the keys too. Have to work on that. I still think that's too slow. I mean, Pong should be fast from that. So 700. This is usually a decent guessing game, for me at least. That feels good. Now we can play fast Pong. Perfect. What else don't we like here? So now we have capped the frame rates to whatever frame rate the operating system or the screen is running at. We fixed this rendering. We just allocate one paddle box and we just move it around for drawing. We don't create one on every loop, which feels nicer. Width and height never changes, so we don't care about that either. To be fair, we should probably yeah, let's clean that up too. So we'll just put a definer instead. Paddle height. Oh, so we have a paddle height somewhere. Oh, so it's there. Paddle height 80. Paddle width 20. Line those, we'll drop those there. Paddle width. Paddle. We don't even need that one, do we? Screen width -2 pedal width. Are they not aligned? Oh, we'll just see what happens. Pedal width. Pedal height. Sorry, I was just thinking aloud. It's hard to explain when I'm coding. Yeah. So we never used the pedal width. That was a bug. So sorry for everybody who's been annoyed by that. I'm sorry about that. I never noticed. That was stupid. But let's leave it like that. These paddles look nice. So cap that. I don't like the keys. They're still annoying. So let's put this one in here as well. Pipe def struct. Button up. Oh, I just scroll it up and down. Up. Down. And controller. And skip down a bit. We'll just give player 1 a controller here. So we have player 1 and controller P1 controller. Can we just declare that 0? I think that should work. 0 is false. So yeah, let's do that. Do it like this instead, and true. Down is true. We can just copy that one, stop it here, drop that version, we'll just change this to false. There, and now instead we want controller up, y plus equals paddle speed times delta time. If we want controller down, y minus equals paddle speed times delta time. Essentially, what this should do is make the controls a bit less sticky. It's complaining. Okay, so we don't need that one anymore. See if that removed the warning. And let's run it. Because what was happening before, oh, but the key's wrong. Before, if you press a key and release it, like if you're holding down or up, so I inverted these. Sorry, I didn't finish my sentence. Before, what was happening was if I was holding up and then I pressed down without releasing up and then release down, it would just freeze. It wouldn't keep moving. Now, if I press both up and down, it stops. If I release the up key, it starts going down. If I press the up key, it freezes. If I release the down key, it goes up. So it was sticking before, and I would have to repress the key to trigger to restart the movement. That's no longer an issue. Now it feels more like a proper game. Also, I hate in some games when you hold both up and down, the character will move either up or down depending on how they implemented it. I prefer this one. If you press both up and down, you go nowhere because you're applying the same amount of force in both directions. So what did we do today? We fixed our frame rate. In the lazy version, we just aligned it with the frame rate of the actual screen. And we introduced delta time. Delta time will keep showing up. It will keep showing up a lot. Actually, I'm annoyed with this one. So can I just paddle speed? If you like that. Then we'll remove it. We'll go up here and define it instead. Paddle speed 700. There. Perfect. That looks nice. So we align the framework, we introduce delta time, so we make everything move the same on different screens. This became an issue. I don't know when higher frame rate screens showed up back in the day. I don't know when this was. I just encountered it once. So I was making a game with a friend and we were testing it on his computer and it was 60 frames and it was running nicely. Then I tried it at home and I had 120 frames per second on my screen, and the character we were fiddling with only jumped half the speed, and I was like, what's wrong? And then it's when I learned that you can't tie stuff to frame rate. Either you make your game run at 60 frames per second everywhere, or you make your objects in your game move on a time step instead of on a frame step. So, which is what we did now. We're telling it to move 700 pixels per second, and each frame we're checking how long did this frame take. So how far should we move this frame? So, and that will be a smaller value on a 120 frames per second screen, whilst it will be twice as large on a 60 hertz screen. Hertz is the word I was looking for. So, and are we happy with everything? Don't have any C-Lang formatting here, so just we have the controller. We don't care about player 2's controller. I guess we'll build an AI for that eventually or something. Should be pretty easy. Set up paddles. I've forgotten these functions that we made. What's the timer? How long have we been recording? 25 seconds. Maybe we should do some cleanup. Should we do some cleanup? We've got the delta time. Oh, that's fine. And we've got SDL quit. We don't have any texture, so there's nothing else. Yeah, we're not doing this nicely, are we? SDL renderer. Is it destroy renderer? Destroy renderer. Yeah. SDL destroy window. So that wasn't nice either. Anybody who noticed that, I'm sorry about that. We missed it. Everything still works. We can move around. Shut that down. Cool. So let's do a bit of cleanup because yeah, it's nice, isn't it? How do we want to do this though? Should we? Let's create context. Okay, so type def struct context. This will be the game context. In that we'll have an STL window, an STL renderer, and we'll increment it. I don't know if context is actually a good name, but I tend to use it. Renderer. What is it complaining about? Oh, probably a bit a pointer. Get back here. There we go. And static context init everything void context x let's do the init. We can just move everything, can't we? And since this one has panic and aborts, we don't need to return -1. It will kind of just crash gracefully. For this one, we set the renderer instead. We assign that to the window. Reference the context there, and then we return the context. Let's see if now a downside here is like no, but this should be fairly useful. I mean, if we ever extend the application to, I don't know, have 2 windows. Let's say we make a second window for a scoring screen. I don't know why we would, but let's just say we could just insert window 2 into the context, so that should be reusable for the future. But as I said, I'm not context x equals now everything. That one will just static or yeah. Let's just call it shutdown. Wait. No. We want the context. Context. Don't want to copy it either. I want to send it in there. And this will destroy the context, so you can forget about it after that point. Do we want to allocate the context? We're copying it now, aren't we? I don't really care if we're copying it because we're copying the pointers and then we're actually using the pointers. I mean, it will be unique. However, when you push it in here, you'll have a local version, won't you? But it will be foobar, and then it will clean itself up. The alternative is to allocate a context and assign to that and then return the pointer. That way we're not copying Yeah, let's do that then. Yeah, let's do that. It's all about discipline, really. I think it would be safe, but yeah, let's do it like this. Size of, because then you can context. So we allocate some memory, which is the size of context. This is now a pointer. It will now complain about all of this. We're using malloc, not cloc, so it will have random values when it starts. Renderer. This is an arrow. This is an arrow now. Return context. And this one should end by freeing the context. So it will take over. And it will also do all of these things too. Let's put those in there. So now we're not copying those, just have one pointer, that's good. This is a pointer now, and shut it down. Yeah, probably cleaner. We have a bunch of renderer references now. Yeah. What? How? Sometimes I just get the order of characters wrong at a tremendous level. I practically wrote shut backwards and then I misspelled it. So that's some cleanup. We have a nice init everything function and we have a nice shutdown function. We have a context now, which is a pointer, and we're not copying stuff all over the place. We're using malloc, but we should be safe with that. Don't worry about it. Just have to make sure that object is only destroyed here. We got paddles. Everything is nice. Everybody's happy. So that's frame rate and some cleanup. That should be it for today. Yeah, we wrote quite a bit of code. Hopefully it was coherent. I didn't get any questions, but yeah. This isn't live, is it? There we go. That's it for today. I'll see what we'll pick up with next time. I guess next time we're doing the ball and collisions and bouncing. So that'll take a while. Have a good weekend, guys.